we're back to here we are starting, and we've got our little LED here. That's what we did for last year. But let's talk about, we brought this up last time. This is the Kaggle contest that I was playing on earlier. And so we were, so I'll remind you all of, so you can make a living almost off of Kaggle's website if you are a brilliant data scientist and really good at data science work and know how to, and got a team to do this. The award you can see is $7,000 for, this was a combinatorics problem, find the shortest path for the reindeer. And then you see all those little dots on that picture, that's actually the path, the cities that you have to visit. And so I was playing with trying to do this. And let me move to the next slide. And then I learned about this item here called Concorda, which is a traveling salesman solving software that you can lease from these folks if you want to use it for non-educational use. But it's a bunch of C libraries. These guys hold the record. They were able to solve a whole bunch of problems already, have already received awards for it. They've been doing it for 20 years. And Mr. Cook there has 2 books on it. I've been reading through their books already to see how they pulled all of this off. And so if you run the Concordia software, you'll get a path about 1.5 million length. Now, and about 1,500 teams on this thing actually ran that. They actually had Juniper notebooks where you could just actually run it, join the contest. And so it was very sad for me because here's here's all of my work, and we got up. I managed to get to 1.84 million by not writing by not using Concordia, writing all the code myself. And so I talked to a couple of folks online that were in the contest, so they were in the 2 millions. And I can tell you that the winning score is 1.1 million. 1.51 million, and I was in the 1,569th place. Obviously not in the money or anything, but I can tell you that I did all the code myself, and I have about 6 hours of runtime on my Apple on it. Most of the guys were winning were into the days of running Concordia and various other solutions. The whole purpose of this conversation for you all is that these contests go, and I learned that there was something called Concordia, and so if I need to solve a TSP problem, traveling salesman problem at Nike or anywhere else, I'll be headed there, because that was people were showing notebooks that within an hour could get as good as I had. Mine's mostly a greedy solution. I then did permutations over short paths to then try to find the right path, and discovered that I kept just switching the 2 endpoints. That was not particularly useful. But this was interesting, and if you know enough about traveling salesman problems, the write-ups on the reindeer contest are PhD level. They're going through really interesting, complicated items and things, and they have a recipe there on how to get to within the 50 point level of the contest. Said you do this, you do this, you do this. You run Concordia, you get your base value, and they went through all this. And so they were actually commenting in some of these conversations how people had given up their positions because they told people how to get higher than them. And so so that's the really fun part about the Kaggle contests, are that people are willing to show their cards. And so I highly recommend Kaggle to you. And the other thing is, we were here last year, and our Intel friends told us to try out the Intel Python libraries. And you can install them if you go to the and look for it on the web. It's actually an Anaconda install, which is even cooler. It just lands it all in there, and also pulls in Intel wrote all of their libraries also, so it's not just Python that brings in all the library. I got a 10, it says on the slide, I got a 10% improvement. And I will tell you, that was what what it was like, that lunch comment there. I've done all this work in the morning because the other thing that I've been learning is, I'll go back one slide, Mr. Cook's book here, he has 2 books. One's about 2 to 3 inches thick, which is how Concordia works, down to every last inch that they could publish back 8, 9 years ago. And then he's a smaller book, paperback book about 1 inch thick, that it seems to be an update. I've only got to the first one, but they're talking how they solved this with an area I'm not that familiar with, but some of you might be, linear programming. And so what they have done is they take the traveling salesman problem and they run a basic trial. And then what they do is they try to turn it into a group of inequality equations, because those are solvable by linear programming solutions, and there's piles of programs. Actually, Concordia started as a linear programming solution, so that was very interesting to me. So if you can, and what you do is you just continually look for slices, or what they have other words for it, to find another equality equation to add to the process, and you then run it again and see how close you are. So Mr. Cook described it this way. I don't know if you know the old joke. There's this old joke about the drunk, and he's on the ground, and the policeman comes up and he says, "What are you doing?" He said, "Well, I lost my wallet." And so they're looking out on the ground, and there's a light post there. And the policeman says, "Well, I don't see it." He said, "I know, I didn't lose it here." We said, "Well, why are we here?" He said, "Because the light's better." and so Mr. Cook said that's what you're doing actually with the traveling salesman problem. You can't solve, this is right out of their book, you can't solve the traveling salesman problem. What you have to do is find a problem you can solve, and then use that to find solutions that are iterative. So in the case of the description here, the joke, take the light post with you. And then you'll be able to find your wallet. And so that's part of what I was learning, is that's how they're solving some of these problems. So it's all educational for me. Now, you'll find my programs are up there on GitHub. You can see I don't know how to spell reindeer. It's Portland. I just couldn't resist. We're in Portland, the rain's pouring down. It was reindeer for me, not reindeer. And then I was able to, the first program that I wrote was, after many other tries, was Deer Path. And Deer Path cuts up the picture into 10 areas and then finds the average point in all of them, and then measures the difference between all of them to that little point. And then I assemble it from that by taking the closest ones and then running a very boring, greedy routine to just connect it all together and create a path that is valid. And a little algorithm called Snake that snakes it around, opposed to going ding, 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 ding. Yeah, I'm having what you call a typewriter problem. And so you need to not have a typewriter problem. And then the next program, Deer Herd, which I went with the same concept, was now that I had a path, I would polish it. And so Deer Path has subroutines that go through and run permutations so wide and checks to see if I take a grouping of 10 or 15 and I run a hard permutation of all 10, are any of those better? Now I will tell you what happened was I kept switching endpoints. And so I had to then put some logic in to remember what I've already changed, and so not to keep changing because what I would do is I would just change it back and change it back and change it back. And so I needed to remember what I had done, and that helped. And that got me to 1.84. I'm very proud of that number because I didn't use Concordia, and it's all my code. And I think if you took deer path and ran it for an hour, and then ran deer herd for another hour, you would probably get almost the same number. And so in 2 hours, you could actually get within, I would say, 40% of the perfect solution that they've been able to find with weeks of work. And so I'm very happy with getting that close with what is almost a Monte Carlo with some thinking in it. So, and you can see I have my snake oil salesman on the on the screen for you. And so that is my experience so far. And then what we'll talk about now is if you would like to go into this adventure some more, I again would suggest you go play in Kaggle. And we did this before, but we'll cover it again because I did some revisions and some improvements. The Titanic set, I highly recommend it to you for two reasons. One is it's easy to understand and easy to write. But the other thing is that all the advice on all of the kernels, the Juniper notebooks, all of that, are so good that they cover all the factors of cleansing data, interpolation, what do you want to use random forest trees, what are the parameters of random forest. There's a guy in Berlin that wrote this cool bit of Python that goes through and runs all the different decision trees and runs through also all of the parameters on all of them. And so it's a really, really fascinating bit of code because you can actually see they did, and it's all out there for you to use. So I highly recommend it. And what you do is you get 2/3 of the survivors of the Titanic with their full information. And then they give you a test set where they don't tell you if people survived.
So what's we can get the notes there in that event, right?
Yeah. And so what you do is you run your program looking at the not so clean data because they give you how are you going to cleanse this data and interpolate it, and then they give you a test set, and then they don't give you those answers. Now, I can tell you the data set's available at Carnegie Mellon, so you can always cheat. You can just load up the Carnegie Mellon data set and get all of it. But what they'll do is show you how to run their contest. And we'll do a little bit of that. And I have inside of my Monty, I did a class for Nike on machine learning, and I re-updated my program called Basic Titanic, so here's some more notes. I couldn't resist this picture right here of the 2018 Titanic. Everyone holding their iPhones over their head to get that last photograph. Yeah. So, and we're going to now come and I will show you, welcome to, let's see, which Titanic do I want? There's all the herds. Let's see if we can, we'll go here in PyCharm and bring up Basic Titanic. And open the new window. So here we are. Welcome to PyCharm. And I use PyCharm because I like it and I had paid for the license myself. I recommend the non-pay license because you don't get enough for the pay license, but nonetheless, and you'll see that I have pulled the test and the train data sets. Those are on the Kaggle website, so you can just you can connect to them. If you use they have Juniper books that will just directly connect and pull everything down, so you don't have to drop them here if you don't want to. But here's our program, and what it does is it reads in all of the data. You can see that it goes through and interpolates it a little bit and then does some scaling even. So we've done the cool kid stuff. We didn't leave the numbers the way they were. We scaled them into a range, and we fixed some of the crazy data about fare, and we messed with the ages a little bit so that, and we dropped some columns that we didn't think we really need. And then we here we are in the, we effectively pull in the data sets. We cut the train data set into 66%. So we'll train with just 66% of it. And then we look.
So you test data and 66% is.
Yeah, for the yeah. And so you'll see that we then use the random forest classifier and just pulled it right in. Again, you can get all of this right off of the Kaggle site, but it's pretty fun. And then once I had that, I actually ran the model. And what I did, and all of this crazy code here, is to extract from the model what happened. Because one of the big problems that you have with machine learning is you really need to know what happened. And a lot of these people just run machine learnings, put them in production, and don't actually know how the answer was formed. And then when they start retraining the model, it goes sideways. And so our model will tell us what it decided. And then it will also, I saved off I took from the training data, I cut it into a third and 2/3, trained with the 2/3, and then took this third to evaluate how good a job we did. And you'll see that that's my despair rating, because I fail 17% of the time. And so I call that despair. I'm sure there's appropriate statistical names for it, but I found it depressing that my program didn't always work. And this is what happens, it overfits. And this really overfits. And we'll be looking at that in just a second. And then we actually run a real prediction, and I create the actual results. You say actual Titanic results. And so there's no reason not to hit run. And so here we are, we're going to execute this, and we get a little warning. And I know you'll find it hard to imagine, but it's already over with. And that's how long it took. And what we see here on the screen right here is my despair levels. And so what you can see is that my despair level is at 17%. So I've found from my tests that I was wrong 17% of the time. Or actually, I think it's 17 I was wrong on, actually. So I was wrong on 17% of them, so yes. And so what you can see is I dumped out the results of my random tree, and you can see that fair and age, misspelled, because I don't know why, but that's how they spelled it. Fair is, and that's how much they paid for the boat, has been used more than male and female sex, which is also interesting, because when I played with this before, we would overfit on the gender. And that's because if you know your Titanic history, women and children first. And so a large proportion of males die because they don't get in the lifeboats. And you can also see that I've been wasting my time on where they embarked from, which is Southampton, Queenstown, or France, which is the sea, Charlesburg. And so that didn't actually help very much. And the free fare, which I went through all this trouble of calculating if someone got a fare that is, free or zero, didn't help me decide very much at all at that point. And so you can see in your mind the decision tree that it goes fair, age, male, female, which are exclusive, but it doesn't know it doesn't recognize that. And so what it's actually saying is, if I'm on the male and then I'm not female, so that's not actually right. So this is a interesting trial, but we could run it in less than a few seconds, and we have 196 lines of code. So not too horrible amount of work. Yeah, not too bad. I've written much more code that got less good results. And you're welcome to harvest this code. It is officially on the Apache license, so help yourself. And then, But the real cool part is to go over here and fail spectacularly. So let's see, can we, oh, are we still up there? My screen
so
not
what
showing.
we're trying to question is it like it's a binary value, right?
Yeah.
Given a person, if he were to be a male and then blah, 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 what is the probability that he will die or alive? Yeah.
Yep.
Is that the question?
Yep.
Good.
Yeah. And then, let's see, there it is. And so what we'll do is, we'll do something even more fun. We'll pop over to the Kaggle website. We will pop over to the Kaggle website. We will pop over to the slow Kaggle website. We will pop over any second now to the Kaggle website. And here we are. And you'll see that there's already here, always interesting questions on the Titanic stuff. Now, and those are going on right now. And there's the Traveling Santa that we talked about earlier. But here's welcome to the test one, Titanic. And what you can do is I will go here and submit a prediction. And I will just go here and upload a prediction. And of course, I've already cheated and have everything set up to go with this one. And so I'll choose the one we just ran. All right. And I will actually run it in. I will save it. And then I will submit and make my submission. And it will now go in and score my result set. And I'm still at 0.74641. I'm only 9,211 of the people, but it will score it. So if I was in a real contest, I'd be trying to win money. And this is how you would actually do that. So I have now submitted a score. Yes?
So what is the thing with CSV? So I may ask, what is the thing with CSV?
They love CSVs.
No. What is
it's like 3 columns, right?
Actually, why don't we look at the here? Let's go a little further. So here is the data that they have supplied to me, and this is passenger ID, the passenger class, the name, the sex, the UGs, which look his names, the siblings, whether they're married or not, the ticket. By the way, you have to figure all this out. There's no real help because they want you to feel like a real data scientist and be terribly lost in this crap data they hand you. And some of the data is blank, as you can see, so they get to use the null data sets. And then our actual result set is the passenger number and 0 or 1, live or dead.
That's your prediction.
Yeah, and that is what we do, and it's really fun to play with this one because. So, for instance, you'll see.
What's the data size? The size of the data set?
Like 500 columns, the rows.
I'm sorry, what was?
How many rows?
There were only 669 survivors of Titanic, and so that's I think there's 669. It may be 75. I can't remember. The number kept changing over time.
Yeah.
Yeah.
So what is the input size?
It's actually here's the test row right here. This will here is the train row right here, and you'll see that they have granted us 892 rows of data, and the data is passenger ID, whether they survived or not. Mm-hmm. And I will add the following fascinating effect for you. If you take this name, let's say Brand Harrison, like this, all right, just copy that, right? Sorry, really copy it. And if you pop over to Firefox, for instance, okay.
You can really Google that.
Or you go over here where it's not having. Oh, now we're gonna. And you can actually. Drop that person's name right here and put Titanic right next to it, and you can get you can look them up on the work. You can look up anyone and know anything about these people. There's this picture. Here's a whole biography of them, and here's actually all the information. He died in the disaster. His body was not recovered, and you can do that anytime you want in this data set. So this is one of the it's a slightly morbid data set, but it is extremely interesting because there's enough Titanic enthusiasts, including myself, that you can find anything you ever want on this, so you can figure out why your model isn't working right or why this person's data is so obscure.
A lot of weather professionals,
One of my favorites is that there is a woman doctor on the Titanic. There are almost no women medical doctors in 1912, but there was one on the Titanic. And she was a second-class passenger, and her husband survived. Now, if you run all the models that I have, because I'm overfitting, he's supposed to die. And so one of the questions that people started, can you check if they're married? Did the spouse live? Because then maybe if they're second class, you start overfitting all the data. So it's always interesting. So I commend to you for anyone who would like to do some machine learning, the Kaggle website and the Titanic Harvest my code, or enjoy the code that you'll find in all of the Juniper notebooks and all the kernels and all the articles. And if you start searching the internet, you'll find the Berlin, there's a Berlin machine learning club, and they have the crazy code that tries every possible combination. So I highly recommend this to you as an opportunity. And then you can also play with my code all you want. Go get your own version of it. Play with it. It is perfectly all right. And you can start trying to fix some of this right here in the data and try to see if you can get that extra little bit. Or the one that I would suggest is maybe you should consider dropping fair from your data set. And then merging without it, and see if you get a better answer than I have, because that fair is obviously not really working right. And so,
if you're using other methods, because you're using the decision tree.
I'm sorry?
If you're using other.
I tried all the other decision trees. I have another one of these with 6 different trees on it, and I've done the same thing the Berlin team has done. And everyone, the best answer is the random tree so far. The random forest, if you can get the data correct. There's a lot of conversations about what is the right settings for some of the interpolations. One of them that I didn't do here is title. Title provides you with a lot of interesting information. Military guys went down with the ship. So if you've got a military title, they're almost all dead. But if you have a royal title, they all lived. It's 1912, I'm sorry. It doesn't matter whether you like that or not. It's just the way the Titanic was. So there's all sorts of ways to consider. So it's an interesting problem. But the good news is that anything you think of, someone else already has done already. And there's a bunch of information on it. So feel free. And then when your program starts going crazy like mine has, which is what the, if you see I have the failed results here, these are the ones I got wrong. and so we can, and you'll see I have a Sir Cosmo here. And he looks like he survived the Titanic, and I said Sir Cosmo should be dead, and so the calculated survival is fail, and that's back to the Sir part, which I just mentioned. So that might be the fix for that, and so I again send all this to you for your consideration, and so we'll finish up now. I still love that picture. And go off and run it. See if you can, I use the random forest. I'm saving off the failures so you can see it. So feel free to harvest that program and score higher than me, and don't tell me. And you can see this is my opinion about artificial intelligence, that don't fear artificial intelligence until Alexa can be actually scary. Because, yeah, so I just, I like that. So I'm done. Here's the last one. Dave didn't make the Turing test.
Good. Thank you.
Thanks. Any remaining questions?